Hey guys, this one is the example of the reinforcement learning that you can find the gym of OpenAI in the internet. You can use the keyword gym and OpenAI. There are many environments. This is the one that we use as the example. For example, this one Acrobat, Carpole, and the one that we will use the mountain car V0. This one. The idea of mountain car V0 is um, you have the one-dimensional track. Uh, just only the x values that enough to define the position. Just only the track here, and you can specify the position of the car by using just only x. Okay, so there are two mountains, the left and the right. The goal is on the right here. This this is a goal. This is your car. Okay, and you have because the car engine is not strong enough, so you have to use the momentum. But the operation that you can use is push to the left, to the right, to the left, and or just do nothing, let the car move. So this is the environment that you can use the Q learning. I This is a quote from the internet, so you can find anywhere, but I try to explain you what are they. Uh, for example, if you start with you have to install Gym first, and I will use the NumPy to store the states. At first, if you want to use Gym, you have to import it, and of course, don't forget to install it first. Uh, you can use gym.make and provide the name to get the environment. And once you reset it and step 0, it means that you do nothing. So this is the position of x, and this is the velocity. To the left, it means that if it's negative, it means that to the left, or if it is moved to the right, it will be positive. Okay, so you can try something like, for example, for I in range, uh, for example, I'll do it the same thing. Okay, if I move 20 times to the left, uh, if I do that thing 20 times, it will like is at the location x is minus 0.6, and velocity is to the left, but very low. But if I move step 1 20 times, let's check. Uh, oh, sorry, I think it's not enough. You can do just only 200 step. Okay, I'll check it. Step 2. Yes, because the car start at like 0 point, I will, it start near the place at minus 0.5. So I think this way is better. Show the result. Can you see? This is minus 0.5. Uh, you do one, the operation 1. So you can see that it's slightly, the velocity slightly change from very low very low to a little bit faster and faster. Okay, but the place is still minus 0.5. Okay, if I do 200 steps, look at the result. This is the starting point here. This is the starting point, and this is the velocity. So you can see that if you move step 1, it will go to the left. The velocity is to the left, to the left. So you can see that to the left, values of x is increasing. Can you see? And until the momentum, the velocity is cannot move anymore. So this point is like the car will stop and velocity turn to the right. Yes, if you were a human, at this point you have to push it back, right? Right? You have to push it back. So, but you push to the left too hard, too many times. So you have just only 200 steps to do. So you cannot do anything. And if the car try to move to the right, in the velocity to now is positive, so it is moving to the right. But you still try to move it to the left. Okay, so this is the result. So if I change it, like I try to move it to the left 100 times, and then I move it to the right another 100 times. Let's see the result. So can you see? Yes, it's interesting. A moment. Yes, it's done because it's time limit here. Time limit. It's true. The steps you can do just only 200 steps. But guys, look at this. We move 100 times to the left, right? Move 100 times to the left. So at first, I think you can see they are at the point minus 0.5, and the velocity is very low to the left. And then you move it to the left, so the velocity is like it's moving to the left here. Can you see? It's moving to the left, and it becomes slower because it's not enough momentum to go uphill, so it moved to the right now. Yes, and then this one, the velocity turned to the right. And again, after the momentum is not enough, it will go back to the left. Okay, so I think you can see that it's a little bit difficult to program by yourself, right? But if we use reinforcement learning, uh, this one is a quote from the internet, and you can see it's try to define the state in using the discrete values, using the space dot high minus dot low, and use NP array 10 and 100 and round it. So it is now it is the number of the position and velocity. Okay, I will show you what is it and what is the values of num state. So you will get the idea what it is, how can they define the state. Okay, this is num states. It is an array of 19 and 15 elements. So the first element, look at this. This one is the observation space high, and this is the lower. The velocity range from minus 0.07 to 0.07, and x, the location start from minus 1.2 to 0.6. Okay, so it divide this number into 19 numbers, discrete numbers, and the velocity divided into 15. So that is the number of state. Okay, so we will create the Q1. That is the one that we used before. This is a Q values, and try to do it. Uh, Look at this. Try to do it 5,000 times, and done is false. And try to get the state, and then while done is not true, and try to find this case. If I is range like 20 last 20 steps will render the animation. Okay. Okay, so this is the way that they choose the action uh, according to the epsilon. Epsilon is 0.05, and if you random the number less than 1 minus epsilon, uh, you will choose the max Q that you learned. But if not, just random. Just random. So the epsilon will control the behavior of the way that you choose. You can random or you can choose from Q table that you learned. Okay. So the values can be step, reward, done, and info. So this one, it will return this one will do the action and check is it done or not, and check the reward and the state, return state. Okay, so look at this. The Q values, the Q values will updated by learning rate times reward, the immediate reward, plus gamma times max of Q of S prime and A prime, right? And minus the Q state, the one that we did. Okay, so this is delta. Okay, same as we did, right? Yep. So you have to copy this and pass into your your maybe you can use your text editor that you want and try to make the file. This one. This one is the file that the source file. So you can use any text editor. Copy and pass it into your text editor, save it, and run it. And what we can see will be something like this. You have to wait because we run it, we iterate it 5,000 times until the last 20 steps. We will show it in the in an animation. So please wait for a while. it will pop up another windows. Sometimes if you, I think you cannot use it on your machine if you have only Python. So you have to install the Gym first, and then it has the PyGlet. So this one is the last 20 steps. So you can see that they have some learn Q table. Yes, it is better, keeping better and better, right? So sometimes it's stuck here. Yes, yes, almost there. Because the rules of this mountain car, you have just only 200 steps. So if you cannot do it in 200 steps, it's fail. So you can see that, yes, that one. We can learn from, yes, that one. We can learn from from nothing and try to move it, like randomly move it, or using the Q1 that we just learned. So we can reach the goal in some state. Yeah, that one. So I hope that you will enjoy it and you can find this source. This is the source that I try to explain in the source come from the internet, so you can find it. And we will have another example in the next video clip. That is the how can we write the program to play the tic-tac-toe.